Thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we continue with our solutions to elective maths 2025 GC. With us here is question 15. In my previous video, we have looked at question 14. Let's look at how we can handle this. Let's consider this question 14 together. The question reads, a car moves along a straight line such that its distance s, that's in meter, from a fixed point or after time t seconds is given by the distance s now equal 2t cubed minus 21t squared plus 60t plus 12. We are asked to calculate A, how far the car is from O at the starting of the journey. B, the times the car is momentarily at rest. C, velocity with which the car starts. D, the distance covered by the car in the 6 seconds. This is under application of integration to kinematics. Let's look at how we can handle this together. Let's write down the solution. That's the first thing to do. Let's write down the solution here. A, we are asked how far the car is from O at the starting of the journey. How far? We are looking for the distance. At the starting of the journey, it means the time is 0. But before we dive into that, let's understand under application of integration to kinematics, we have to understand certain concepts. As far as this application of integration to kinematics is concerned, sometimes they will give you distance or velocity or acceleration. These are the 3 key dimensions they may give you. Very important. When distance is given and we want to find velocity, we differentiate. When velocity is given and we want to find acceleration, we still differentiate. So it means when we are moving down like this, we differentiate. We differentiate. Very important concept, we differentiate. But when acceleration is given and we want to find velocity, we are moving up now, this way. When acceleration is given, we want to find velocity, we integrate. When velocity is given, we want to find distance, we what? We integrate. Meaning we take the integral of the given function. Very important concept. Okay, let me repeat it again. When distance is given, we want to find velocity, we differentiate. When velocity is given, we want to find acceleration, we still differentiate. But when acceleration is given and we want to find velocity, we integrate. When velocity is given and want to find distance, we integrate. Very important concept. So with this knowledge, let's look at how we can handle this question now. First question, that's solution to A. We are asked to find the distance. The distance that is given from the question is S, which is 2t cubed minus 21t squared plus 60t plus 12. This is the distance that's given. The question now says how far the car is from O at the starting of the journey. At the starting of the journey, t is 0. Velocity is 0. So t is 0. The initial velocity is 0. The system or the car is not in motion. So if the car is not in motion, the velocity is 0 and the time is 0. So let's substitute t equals to 0 into this function and see. Okay, so distance now we are asked how far is the car. So the distance now will be anywhere we see t, we put 0. That's 0 cubed minus 21 into 0 square plus 60 into 0, then plus 12. So the whole of this will give us 0 plus 12. So the distance s now will be 12 meters. So how far the car is from O at the start of the journey? The car is nothing but 12 meters. from O. The car was 12 meters from O. So this is the solution to A. Very simple and direct. Let's move to B. Permit me to clean this A so that I can have space to analyze B. Solution to B now. The B, so times the car is momentarily at rest. The time the car is momentarily at rest. When a car is momentarily at rest, the final velocity V is zero. Very important concept, meaning we have to find the velocity. In this case, we have to find the velocity and equate it to zero and solve for t. So the distance is given as 2t cubed minus 21t squared plus 60t plus 12. When distance is given, to find velocity, we are going down now, we differentiate. So v, which is velocity now, is changing displacement with respect to changing time. Will now be, we differentiate this using general formula of differentiation. So these three will drop down and multiply this. We have 6t squared, the power will reduce by 1, minus these two will drop down. 2 times 21, that will be 42t. Then plus, when we differentiate 60t, we have 60. The derivative of a constant 12, of course, will be 0. So this will be the velocity. And at when the car is momentarily at rest, v is 0. So let's equate this to 0 and solve for t. T squared now minus 42t plus 60 will be equals to 0. Let's reduce this. We can divide through by 6. Let's divide through by 6 because 6 is a factor. So that we can have t squared minus 42 divided by 6 is 7t plus 60 divided by 6, that's 10. So we have t squared minus 7t plus 10. Can we factorize this? Yes. So let me remove part of the question since we are almost there. Let me remove up to this point. Yes. So let's factorize this. We have t squared minus 7t plus 10. Two factors of 10 that can give us minus 7t. Very important. Check the middle term is negative. The last term is positive, meaning the two factors has to be negative, and it's nothing but minus 5 and minus 2. So this will be t squared minus 5t minus 2t plus 10. We can group this and factor out. What is common here is t into t squared divided by t is t minus 5t divided by t will be 5. What is common here is 2 into 2t divided by 2 will be left with t. 10 divided by 2 it will be minus, that's 10 divided by minus 2 will be minus 5. Very important. Okay, so we are asked to find the time now. We are looking for t now. Let me clean here. We are looking for t. You realize that what we have in the bracket are the same. Let's pick what we have outside. T minus 2, then t minus 5 equals 0. Either t minus 2 is equals to 0 or t minus 5 is equals to 0. So we will have that t is 2 seconds or t will be 5 seconds. So this will be the time. The question says the times the car is momentarily at rest. Meaning we are expected to get two values of t. Okay. Next question: velocity with which the car starts. Which the car starts. Velocity which the car starts with. Let's look at it. To find the velocity which the car starts with, we know our v. Let me remove up here. Our velocity, when we differentiate before v, it was 6t squared minus 42t plus 60. This is our velocity. Velocity with which the car starts. Mind you, the time when the car is momentarily at rest, we know the time, but we're looking for the velocity with which the car starts. To find the velocity which the car starts with, we have to substitute when t is 2 and when t is 5. Velocity with which the car starts. So to find the velocity which the car starts with now, we use this time when t is 2 and when t is 3. a 5. Let's substitute. This will be 6 into 2 square minus 42, 2 plus 60. V now will be, this is 4 times 6, that's 24, minus 42 times 2, that will be 84 plus 60. So 24 minus 84 plus 60 plus 60. If when t is 2, the velocity will be 0. Okay? Uh, when t is 5, what will be the velocity? Let's use when t is 5. V now will be equals to 6 into 5 squared minus 42 into 5 plus 60. Let's check this. 25 squared, that's 25 times 6. That's, we have 150 minus 42 times 5. That's 210 plus 60. It will still give us 0. Velocity with which the car starts. The velocity which the car starts with, it will be 0. So it means the velocity with which the car starts, at the start of the car, the velocity v, the time is 0. So we substitute t as 0. Sorry, we substitute t as 0, not using t as 2 or 5. Velocity with which the car starts, at the start of the journey, t is 0. At the start of the journey, t is 0. Velocity with which the car starts with, it means t is 0. Let's substitute t as 0. 6. Anywhere we see t, we put 0 now. Plus 60. This will be 0, this will be 0. V now will be 60 meter per second. So the velocity will be 60 meter per second. We can't use t, 2 or 5. No, because this is the calculated t. Okay, so this is the solution to C. 60 meter per second. Let me write here, solution to C. The last part now will be solution to D. Let's look at solution to D. Solution to D. The distance covered by the car in the 6 seconds. This word 6 seconds is key. 6 seconds means it's not exactly 6. It's between 5 and 6. So we'll look at it when t is 5 and when t is 6. We substitute into the distance s, which is 2t cubed minus 21t squared plus 60t plus 12. So when t is 5 now, what will be the distance? So let's substitute 2 into 5 cubed minus 21, 5 squared plus 60 into 5 plus 12. What will be the distance in the fifth when t is 5? Okay, 125 times 2, that's 250 minus 25 times 21 times 21, that's 2, that's 525 plus 60 times 5, that's 300 plus 12. Very important, 125 times 2, that's 50. Let's add 250 minus 525, 525, then plus 300, then plus 12, we'll get 37. So let me take it here, up here. Our S5 now will be 37. We are almost there. Let's find S6 before we subtract. S6 now we substitute. When t is 6, that will be 2 into 6 power 3 minus 21 into 6 power 2 plus 60 into 6 plus 12. 6 power 3, 216 times 2, that's 432 minus 36 times 21, that's 756 plus 60 times 6, that's 360 plus 12. 432 minus 756, plus 360 plus 12. That will be S6 is 48. The distance covered now by the car in the 6 seconds will be when t is 6 minus when t is 5. That will be 48 minus 37. What are we going to get? Minus 37, that will be 11 meters. This will be the distance. So this is the solution to D. Thank you for watching. Please do share this to your learned colleagues and don't forget to subscribe to TJ's Maths Clinic for more interesting videos. You can follow me on TikTok, Instagram and Facebook. See you in my next video.